Lesson 70, consecutive integers. Let's review integers. Integers are numbers that have no fraction or decimal part. They can be positive or negative. We see them marked here on the number line, including 0, positive numbers, and negative numbers. Each integer, notice, is 1 greater than the previous integer and 1 less than the following integer. -1 is 1 greater than -2, and also 1 less than 0. So for any integer, n, we say that the next integer is equal to n plus 1, the one after that is equal to n plus 2, etc. We can use this to solve certain problems where we're dealing with consecutive integers. Let's take a look at one. Find 3 consecutive integers such that the sum of the first and third is 142. So while it may look like we're dealing with a problem here with 3 variables, in fact there's only one variable because we know what the relationship between these 3 integers is. The first one we can call n. The second one, because it's consecutive, will be equal to n plus 1. And the third one will be n plus 2. Then we can use this to set up our equation to solve. So since we're adding the sum of the first and the third, we have n plus 2 is 142. Now notice here that I've put the n plus 2 for the third integer in parentheses. That's not necessary here because we're only dealing with addition, but it will be important for more complicated problems. Then we can solve by combining like terms. 2n plus 2 is 142. Move the constants over to the right side, leaving the variables on the left. 2n is equal to 140. And then divide by 2 to get n is equal to 70. Now we're not done here because we're looking for 3 integers, not just one. So n, that first one is 70. The second one is 71. And the third one is 72. So our answer is 70, 71, and 72. We can check our work here by taking the first and the third and adding them together. 70 plus 72 equals 142, and in fact it does. Let's look at a more complicated one. Find 4 consecutive integers such that 8 times the sum of the first and the third is 40 greater than 10 times the fourth. So here we have 4 integers, n, n plus 1, n plus 2, and n plus 3. Now we need to make sure we set up this equation correctly. 8 times the sum of the first and the third. So the first is n, the third is n plus 2. The sum of the first and the third is n plus 2. And 8 times that sum, we need to put it in parentheses because we're adding them first and then multiplying by 8. Is 40 greater, 40 plus, 10 times the fourth, 10 times n plus 3. Now it's very important here that we put the parentheses around n plus 3 because otherwise we won't get a correct answer. So because n plus 3, that's the value of our fourth integer, we're taking that whole value and we're multiplying by 10. So we need to make sure we put that in parentheses. Then we can combine like terms inside these parentheses. 8 times 2n plus 2 equals 40 plus 10 times n plus 3. Distribute, we get 16n plus 16 on the left equals 40 plus 10n plus 30 on the right. We combine our like terms. 16n plus 16 equals 10n plus 70. Move our variables over to the left by subtracting 10n from both sides, and move our constants to the right by subtracting 16 from both sides. We get 6n equals 54. To get n by itself, we divide by 6, and we get that n is equal to 9. Now there are 4 integers we're looking for here, so there'll be 9, 10, 11, and 12 is our answer. Let's check our work. So 4 consecutive integers such that 8 times the sum of the first and the third. So the first is 9 and the third is 11. So the sum of them is 9 plus 11. 8 times that is 40 greater, 40 plus, 10 times the fourth. The fourth one is 12. 9 plus 11 is 20. 10 times 12 is 120. 8 times 20 equals 40 plus 120. 160 equals 160. That's correct.